the initial concentration is 0.1 molar, right? And the initial concentration of H plus and A minus are what? 0. So you want to solve for X, which will be H plus. Okay, is anybody finding an answer for pH? Okay.
Did you write out every step?
Yes, okay. Let's move this one. Come on, erase. I can't erase it there.
You wrote it sharp.
Okay, so HA plus. Oh, I'm sorry, are you joking?
You said you wrote it sharp.
Yes. Plus H plus OH minus, okay? So this is my reaction. This is 0.1 molar. This is 0, and this is 0, okay? So this is minus X plus X plus X. So I have 0.1 molar minus X, or 0.1 I should say minus X. Let's just do that.
Wasn't it 0.01 molar?
That's 0.1. So my Ka equals X squared over 0.1 minus X. You okay with that? Okay. So they gave me the Ka was equal to, what was it, 6.5 times 10 to the negative 5? Is that what it was? Okay. So I can maybe drop X. Okay. If I drop X, did anybody find out if it was valid? It was what? 4.8%. So it was valid. Okay, so we can drop X. All right. So then I'm going to get 6.5 times 0.1, because I'll move 0.1 up, equals X squared.
Can you explain the valid thing again? You said it's over
5%, but I can't remember how to.
Yeah, how do you spell?
So we're gonna do that right now. We'll do it after we finish this, okay? So if X squared equals this, okay? So X squared equals, what is 6.5 times negative 5 times 0.1?
6.5 times 10 to the negative.
Okay, and then I take the square root of both sides, whoops, and X equals what?
0.00255. 0.00255.
Okay, so this is what my X is equal to. And then to find the pH equals the negative log of the H plus ion concentration which equals here it's going to equal 2 point, what'd you find, 59? Is that what you guys were getting? If I take the negative log of 2.5 times 10 negative 3, 2.59. Okay? Oops. It should be A minus, yeah. Okay, so that's how I'm going to do that first one. Okay? Now try to work on this one. pH equals 6.2. Calculate Ka for the acid. Initial concentration is 0.01 molar. So set up a rice table just like you did.
So we're doing a rice table for which one now?
For this one.
What was the last one we did?
The last one we did was that first question.
Oh,
These are two different questions. Started the same way. from last time?
Yeah.
So, from last time, if I take 2.5 times 10 to the negative 3, which is equal to x, right? And divide it by the initial concentration of 0.1 times 100. If that's less than 5%, then the assumption to drop the minus x was valid. Yeah, because it's so insignificant it doesn't matter. Okay, so like I said on this one, we're going to start out with the same kind of rise table. HA, because it's an acid, to H plus A minus. We want to find the Ka for this. So we have 0.01, we have 0 and 0. What is the negative log of 6.20? So 6.3 times 10 to the what? Negative 7 is the H plus ion concentration at equilibrium. Okay? So that means I know what x is. X is 6.3 times 10 to the negative 7. So I can replace all these with 6.3 times 10 to the negative 7. 6.3 times 10 to the negative 7. And this is minus 6.3 times
6.3 point whatever, where is that coming from?
the anti-log of 6, so 10 to the negative 6.2 is the anti-log of the pH, which will give me the ion concentration, the H plus ion concentration. Okay, the anti-log of that. Okay, so 0.01 minus 6.3 times 10 to the negative 7 is approximately 0.01. Agree with me on that? We're just pretty much going to drop x there anyways, because that's such a this number is so much smaller than this one. It's not really going to change it. We're okay with that? Okay, so Ka equals 6.3 times 10 to the negative 7 squared divided by 0.01.
And then why did you say you were able to put so you got the anti-log of pH, you got the concentration of
H plus.
H plus. And then why did you put it for all of them?
Because this started out at 0, right? And it became 6.3. At equilibrium, it was 6.3 times 10 to the negative 7. That means x is 6.3 times 10 to the negative 7. So I replace all the x's with 6.3 times 10 to the negative 7. Okay, so what do we find for this? The Ka of this is what? Say it louder.
3.98 times 10 to the negative 11.
Okay.
On the percentage thing on the last one, what did you get the top?
This one, 2.5?
Yeah.
That's the x.
So now it's got 20
So when I find out what x is, I then see if I can keep this assumption of dropping this minus x by calculating x here, and then relating it back to the 0.1 molar. And if it's less than 5% of it, then I can keep it. If not, then I got to do the quadratic equation. Okay, so are we okay on this one? So that's two. I use the rice table for both of them. One of them I am given a Ka, which should indicate to me that I'm going to solve for x using that Ka. This one, I am not given the Ka. They want me to solve for the Ka. That means I'm going to be given enough information to be able to fill out my Rice table so that I can find the equilibrium concentrations so that I can calculate my Ka. You can only calculate your Ka if you know all the equilibrium concentrations. Okay?
Just like any other Ka or
Or
Kb.
any equilibrium equation.
It's
Products over reactants.
Got it.
That's right. So it's these two things squared over the 0.01.
Can you see again, to find out if it's less than 5%, you look at the,
So for this one, we don't need to do that.
no,
We don't need to worry about less than 5% for this one.
why?
Because we're not solving for x using a Ka. We have x already. Okay? But this one, we're solving for x using our Ka, so that's when we need to relate it. And see if ours.
Can you repeat again which numbers you're, because I don't have that in my notes. I didn't write it down. So
Which
just so I can
numbers?
have it written down, how to figure out if it's the 5% approximation, like which numbers I'm looking at exactly.
Okay, so the initial concentration is 0.1 molar. Okay, I am making the assumption that minus x, 0.1 minus x isn't going to change the concentration of 0.1 very much. So if I drop it, it just rounds up back up to, if I keep it, it just rounds back to 0.1 anyways. Okay, so that is a valid assumption if this is small enough.
So if the concentrations are small enough, then I can do that.
And you can do that. And the way I know if it's small enough is I take the concentration that I figure out for x, which is 2.5 times 10 negative 3. Okay? So I didn't have to do the quadratic equation here because I dropped this negative x. Okay? So I get 2.5 times 10 negative 3. And then I divide that by 0.1, which is the initial concentration, times 100. And if that is less than 5, then it's okay. It's a valid assumption. Because this number, 2.5 times 10 negative 3, is less than 5% of 0.1. Barely, right? It was just barely. But it was. So it was valid. But it was close to being. I think it's. Okay, so here is a similar question. Okay, so solve for KB. What's the equation for a base? What equation am I going to use here?
A to the negative plus
Okay.
H2O
A minus plus H2O.
HA plus
HA plus OH minus.
And this is the equation for a
base.
base.
For equilibrium of a weak base.
Oh, you
Solids
just
in the
sure.
base.
Yeah.
I mean, H2O is a liquid.
Yeah, it's a liquid. This is what you guys are getting? Approximately? No?
7.
Times 10 negative 7? Ah, that's close enough. I'm sure. I'm sure it's. What'd you guys find for the OH minus ion concentration?
4.57 times 10 to the negative 4.
Okay, so essentially here, to find your KB, KB equals x squared over 0.3. KB equals 4.57 times 10 to the negative 4 squared over 0.1. Is that what you were getting? I'm sorry, 0.3.
And that number that you put there is on the bottom is the anti-log of the pH, which is the concentration.
Nope. It's the anti-log of the pOH. So from the pH, you find the pOH by subtract 14 minus 10.66. And then take the anti-log of that. And you'll get 4.57 times 10 negative 4.
Where are you
Somebody's
using that anti-log? Like, why do you choose that number? Yeah.
because we have an OH minus, not an H plus. This is a base. So if it's a base, I get OH minus. If it's an acid, I get H plus. That's why I'm solving for a KB here instead of a KA. Okay, so I'm going to move on to buffers now. So that's basic acid base, finding the KAs or calculating the H plus or the pH or the pOH minus from the initial concentration if you're given the Ka or the Kb. Okay, now with buffers we're going to use the Henderson-Hasselbalch equation. pH equals the pKa plus the log of the base over the acid. Okay, so this is the Henderson-Hasselbalch equation, and the base acid are in concentration units, molarity. Okay, so I want to calculate what is the pH equals what if NH3 equals the concentration of NH3, equals 0.2 molar, and the concentration of NH4Cl is equal to 0.2 molar. Okay, let's see, this is for, and I'll tell you the Kb equals 1.8 times 10 to the negative 5. Sorry, say your question. NH4, yes, I'm sorry. NH4Cl. take the KW and divide it by the KB, and that'll give you your KA. Or to find the KB, you would take the KW divided by the KA. One times 10 to the negative 14 is the KW.
B would be the NH4. The other
Which one has more hydrogens?
Oh, yeah.
The one with more hydrogens is the acid. What's that?
Yes. For this one.
Yes, this one's easy, right?
Yeah.
Yeah, because the log of the base over the acid is 0, so the pH equals the pK. The negative log of the Ka.
Oh,
Okay, so what is the pH here? Say it again. 2.1. Okay. Usually it comes out to be more like 9.25. Is that what you guys were getting? It's close. I mean, you would find it. I was just not used to hearing 0.21. Okay. For NH3. All right. So 9.25 is your pH here, which is also your Ka. Sorry, pK. Your pKa is 9.25. Your Ka here would be 5. Sorry. 5.55 times 10 to the negative 10. Okay, let me rewrite that. 5.55 times 10 to the negative 10. Okay. That's my Ka. So I take the negative log of 5.55 times 10 to the negative 10, and I get a pH of 9.25. Okay. Now, that's part A of this question. Part B, what is the pH of the buffer after the addition of 10 milliliters of 0.1 molar HCl? So I'm going to add 10 milliliters of 0.1 molar HCl to 65 milliliters of the buffer. I'm sorry, say it again. I want to know what the pH is now. What's the pH? Okay. What's the first thing you need to do to set up your rice table? What is the first thing you need to do to set up the correct concentrations of your rice table? Figure out the dilutions, right? The molarities, the new molarities. Because M1V1 equals M2V2. Good. Figure out the molarities and then set up your rice table. M1V1 equals M2V2.
And you said we need to do the dilution
because you're taking 10 milliliters of something and adding it to 65 milliliters of another thing. So therefore, you're diluting both of those things. The volume is increasing for both items. Anytime the volume increases, then here it's going from 65 to 75 milliliters, right? The final volume is 75 milliliters here. So that's a new volume. We have to find the
So
dilution.
anytime both volumes increase, use the dilution equation?
Yep.
So it's going on from the first part, right? So RN1.
Yes, it's going on from the buffer, the 0.2 molar buffer
Oh yeah.
earlier. Okay, so you took that buffer and you diluted it.
So after we find the M2, that is
That's the new molarity. That's the initial concentration.
for both NH3 and
Well, if you find it for one, you find it for the other,
yeah.
and then you need to find it for HCl also. Okay. What is the concentration of HCl that you're adding? That you added, I should say. What is the initial concentration of HCl in this reaction? Don't forget to find it for HCl.
Oh, so this.
You guys look a little confused. So, what's going on here? I'm taking this base, NH3, and I'm reacting it with H plus, which comes from the HCl. Okay? And it's going to, sorry, it's not going to do an equilibrium here.
We can take off the chloride because it's just a carrier. Is that what that's saying? Is that what you're saying?
Yes, it's just a spectator ion. It's just it delivers the H plus. Okay, the NH3 is going to react with the H plus, and it's going to produce NH4 plus. Okay.
I mean, we just have to like look at it and figure out that stuff.
So here is 0. What did you guys find? What's the dilution of NH3?
0.154.
0.154. 0.0154 here. And then how much H plus is added? What's the dilution of the H plus? Nope. Diluted it. We diluted it into 75 milliliters.
Wait, so that number then that we found, this 0.0154, did we subtract that from the NH3 or that is the new?
That's the new constant. That's M2, right?
Okay.
M2 is 0.0154. What is H plus? Okay, so H plus would be 0.1 times 10 equals X, the new molarity, times 75 milliliters. Is it 75? Am I right about that?
60.
Nope, because we added 65 plus 10 is 75. For this, you got a different number for that one? You guys were using 75, right?
Yeah, I was.
Some of us did.
Okay, so is this number correct?
Oh,
No.
0.013.
Okay.
Times that by 60.
Okay, so what is the H plus ion concentration? This one's 0.013 also?
No, no, no. Sorry.
How do you,
Oh, sorry.
how do you get that? With what you wrote on the box?
That's, yeah, that's for the base. That's
What do
for
you
the
mean?
NH3, so how do you figure out the H plus solution?
No, this is for the H. This, if I was doing it for NH3, it would be 0.2 here. Times 65, right? Divided by 75.
Oh, so that's way off. So 0.013 is H plus.
Okay.
Oh, no shit.
Okay. 0.013 for H plus. What is the NH3 then? So, say it louder. 0.173. Okay. All right. Is that just completely confused everybody, or are we okay now? Okay. So this one is for the H plus, which was 0.013, and earlier we got 0.2 times 65 equals X times 75 milliliters, which is the final volume. After I add 10 milliliters to 65, I get 75 milliliters. Okay? And this is equal to 0.173. These are the initial concentrations of the reaction. When I put those two things together, the buffer and the H plus, the HCl, the buffer and the HCl put together, these are the concentrations that I start with because it dilutes everything. We have to have the diluted concentrations. Okay? All right. Now, the H plus is going to react with the NH3. That means the H plus is going to completely go away because there's more NH3 than there is H plus. So this is minus 0.013, which goes to 0. This is minus 0.013, which goes to 0. And this is plus 0.013, which becomes what?
That one won't go to 0. The NH3 will
Say it again.
The first one, it does not go to 0. It's
Oh, I'm sorry. What did I?
0.0.
Absolutely, it doesn't. Okay, what is it? We need that concentration.
0.16.
0.16. Okay, and then over on the other side, 186. Yeah. Okay. Okay. So these are now the concentrations that I have before it reaches equilibrium. Okay, that's good enough. That's all I really need. Okay. Because now I can use Henderson-Hasselbalch. pH equals the pKa plus the log of the base over the acid. What is the base over the acid? Which one's the base? Good. Over this. There you go. And I can easily solve for my pH now using the Henderson-Hasselbalch.
The Ka doesn't change.
No, because it's for the same thing. It's for NH3, or it's for NH4 plus. The K for NH4 plus. It's the same. It never changes. Use the same Ka because it's for the same reaction. We just added something to that buffer.
So diluting is not.
It doesn't change the Ka. No. The only way I could do that is through temperature. But that's not what I did. I didn't do anything with temperature. Temperature stayed constant. All I did was add acid, H plus.
Those up there go point 116. How did you know to add it to this side and subtract it to this side?
Because this is where the reaction is taking place. The reaction is between NH3 and H plus. So when NH3 reacts with H plus goes to 0. It completely goes away. And that means I've taken away that exact same amount of NH3. And I've added it and it's become NH4. So we have to add it that exact amount to NH4. So that's what it
You
became.
can also see that you're adding like an acid to it. Conceptually. Adding an acid.
That's right. So it's a base reacting with an H plus becomes an acid, becomes the NH4 plus.
If we see an equation like this and there's a coefficient out in front, like let's say there was a coefficient out, just hypothetically out in front of 2 and H3,
Then you couldn't use Henderson-Hasselbalch
okay.
because it would change everything. You'd have to use the quadratic equation, but you're not going to see any like that because the acid-base equation doesn't really have coefficients. It's mostly just all the 1-to-1-to-1 ratios. So if it was an equilibrium question, you might see coefficients. But with acid and base, you usually do not see coefficients. So this would be the general idea.
So when we do the log for base and acid, do we do it like in the calculator? Can we do it log parentheses like this of that, or do we have to do the log of each separately and then divide it?
No. Don't do that. Find the ratio and then take the log of it. Or do it like you said, log of the parentheses, the ratio. But take the log of the ratio. So if you find the decimal ratio of that and then take the log of it, that's a way to do
It's
it.
actually log of B minus log of A.
Okay, so what'd you guys get for your pH here?
9.189.
Okay. 19. 189. Okay. Okay, so that's my pH. So it went from 9.25 to 9.19. Okay, so it didn't change very much, even though we added a bunch of acid. It didn't change very much. Okay. Did you say bummer?
No, it's a good buffer.
Oh, good buffer. Bummer, it doesn't change. Okay. All right. So pH of 1 liter of buffer, that is 1.0 molar CH3COO Na and 1.00 molar CH3COOH before let's see. Let's just start there. And then part B is pH after adding 0.08 moles of NaOH. And C is pH after adding 0.12 moles of HCl. Okay, Ka equals 1.8 times 10 to the negative 5. So find the pH first of the initial buffer. And then after the addition of 0.08 moles of sodium hydroxide and 0.12 moles of HCl. Separately, not this and then this. It's just what is it if you add this to that, and then what is it if you add this to that. Okay? So these are individual. A and B are both individual. They're not one after the other.
So you wanna know the pH of the buffer, so we have to get a KB.
You don't need a KB because it's the pH equals the pKa plus the log of the base or the acid. This question is a little different because it doesn't require dilution equation.
Equation for the second or third. So it would be obviously something plus OH into something.
Okay, what's going to react with OH?
Your guess is as good as mine.
Is it? Maybe my guess will be better than
Your
yours.
guess would be much better, probably.
Okay, so which one is CH3COONA the acid or the base?
Base.
That's the base, right? That's an acetate, and this is acetic acid.
Right.
Which one of those two things is going to react with OH minus?
The acid.
The acid.
So it would just be the H. Because the acetate is just the, or is it the other way around? Just the acetate.
Okay, so the equation will be CH3COOH plus OH minus produces CH3COO minus plus H2O. Okay, so the acid reacts with the base. And this way. And then from this equation, I can find my new concentrations of acetic acid and acetate, and then calculate the pH. Did anybody find the pH for this top one?
4.74.
Good, 4.74.
That was easy. Got that.
Okay, that's right, that one's easy. pH equals the negative log of the base or the acid. The ratio becomes 1, so the log of 1 is 0, so pH equals the pKa. So I simply take the negative log of this, and I get 4.74. Okay? Because it's equal concentrations. So whenever you see that, you should know negative log of the Ka is the pH. Okay? So that should be pretty fast, simple. Now, this one, pH after adding 0.08 moles, I didn't add volume, I added moles. They didn't say you added this many milliliters of this molar solution. They just said you added this many moles of sodium hydroxide to that 1 liter. Well, because it's 1 liter, that makes determining the molarity very easy. What is the molarity of 0.08 moles divided by 1 liter? 0.08 molar. What is the molarity of 0.12 moles of HCl divided by 1 liter? 0.12 molar. Okay? So, what is the concentration here? 1 molar, right? 1. What is the concentration here? 0.08. What is the concentration here?
1.
1.0 molar, 0.08 molar, 0.1 molar. I'm sorry, well, I'm doing 1.0 molar. Okay, and that's going to change the ratio.
So we don't have a like subtract or add or integrate to any of it like we did before.
You absolutely, you do. That 0.08 molar is reacting with 1 molar acetic acid. So you have to subtract. This goes to 0. This gets subtracted by 0.08, and this you add 0.08.
The second one would be, or third one, would be CH3COO basically, plus H, which makes CH3COOH.
Oh, for C?
Yeah.
That's right. So, yeah, so CH3 COO minus plus H plus, because we added HCl, produces CH3 COOH.
It's to the initial, right? Not after.
So this is going to be 1 again, okay? 1 and 1, and this is going to be 0.12. Okay, did anybody find the pH at B?
4.81.
Okay. So it definitely should increase because we're adding hydroxide, right? So it's going to increase the top number, so that's going to cause the pH to go up. And before we calculate this one, the pH should be above or below 4.74.
Below.
Below, it should be lower than because we're adding acid. Here it goes above it, here it goes below it. Okay, so did anybody find a pH for C? 4.64. Okay? Good. We can take a break. We'll take 10 minutes.
I'm just confused how we got these pHs on these two.
Okay. So here, so you have everything right here. So we're going to say this OH is reacting with this.
Yes.
Okay? So that's why we have a single arrow, because it's just going one way. It's creating the acid. Okay? Minus 0.08 molar, because
That's what's
it's going to
getting mixed up.
completely go away.
Okay.
All of this will react into here because there's more of this than there is here.
Okay.
Okay? So this is going to go to 0.
Uh-huh.
This is going to be minus 0.08 molar
Okay.
as well. And this is going to be plus 0.08 molar. Okay, so 1.08 molar. And then this minus that, sorry, 0.92 molar, right? Okay, so now I just use my same equation for how I got this. pH equals the pKa plus the log.
Okay, yeah, I was gonna ask you about that one too, because I was confused how we plugged that in.
For this one or this one?
Well, after this, I was gonna ask you about this one
Oh, for
because
that
that
one.
confused me.
Okay.
That was
Plus
for
the
other
log
question.
of the base over the acid. Okay.
Okay.
So this one is the acid.
Uh-huh.
This one is the base.
Okay.
So it's going to be
It's
pH.
because this has more hydrogens, right? That's the acid.
That's right.
Okay.
That's how you'll know. Equals 4.74, which is the pKa,
Uh-huh.
plus the log of the base, 1.08 over 0.92.
And then just plug that in to get that pH.
Yes.
And then do the same thing for this one after subtracting that from there and
Exactly.
adding that to there. And
Exactly.
do I still use the 4.74?
Yes, you do, because that's your pKa.
Okay,
Because
for the whole.
the Ka is 1.8 times 10 negative 5. If I take the negative log of that, it gives me 4.74.
Okay, okay.
So the reason that negative log of that is 4.74 and the pH is 4.74 because these concentrations are equal.
Okay.
And the ratio is 1 over 1, which is 1. The log of 1 is 0, so pH equals 4.74 in that case.
Okay.
Okay?
Thank you.
This one?
What that actually equates to.
Yes, I want to know what the ratio is, the decimal.
That would be like really hard to figure out the equation.
Oh, no. No. You want to find the ratio. Okay, so calculate. Okay, so on this first one here, calculate the ratio of CH3CO minus divided by CH3COOH. Okay, the base over the acid, find out what that ratio is. If your pH is 4.5 and your Ka is 1.8 times 10 to the negative 5. Okay, so what equation am I going to use?
What's his name?
Henderson Hasselbalch. Good. So I'm going to use pH equal to the negative log of the, Yes, pH equals a negative log, but in this case it's pKa plus the log of the base over the acid. So this term, base over acid, just becomes x. Okay? That's what you're solving for. Plus or times x. That's what I want to find. Okay? Okay, what did you figure out? Did anybody figure out what x is there?
2560. The ratio.
5, 6?
569. 57.
Okay. Good. Okay, so that's what my x is. So here, you would take your pH minus your pKa over here, and then you can solve for x by taking the anti-log. Okay.
The anti-log of pH.
Of this pH minus the pKa, whatever that comes out to be. Take the anti-log of it, because if this is the log, you're to move the log over here to take the anti-log.
And what is the pKa?
Okay, let's set it up. Okay, so pH equals pKa plus the log of x, because that's what we want. We want to find the ratio there. Okay, so my pH was what? 4.5? 4.5 equal to 4.74, which is the pKa of 1.8 times 10 to the negative 5, plus the log of x. Okay, so 4.5 minus 4.74 equals the log of x. What is 4.5 minus 4.74? Negative 0.24 equals the log of x. So to solve for x, I need to take the anti-log, which is 10 to the negative 0.24 equals x. Okay? Oh, it's rotating. My screen was rotating, so. Okay?
I'm sorry, 4.74 because.
Okay, so my Ka equals 1.8 times 10 to the negative 5. So my pKa equals 4.74, which is the negative log of the Ka.
I said you had to do so.
Okay, so if I wanted to create a solution, an acetic acid buffer solution at a pH of 4.5, then I would need to make sure my ratio of acid and base was at that ratio. Okay, that's the purpose of this. So I would, it's a x equals 0. What was it? 569. 0.57. Okay. So that's what my ratio would need to be equal to. It doesn't matter how much of either thing I use as long as the ratio equals this.
So every 100 milliliters of acid, you have to add 57 milliliters of base. Right?
I would need, yeah. Okay. So let's look at the next one. Nope, that's not the one. This one. Okay. Calculate the ratio. So this is the same question, just different Ka, different pH. All right. So using the same pH equals pKa plus the log of x. What's the pKa here?
6.377.
Okay. So that's my pKa. My pH is 8. I'm going to solve for it the same way. Okay, what are we getting for x? Okay?
That shouldn't be to the negative, right?
What do you mean to the negative?
For the anti-log, because it's going to be, you got log of x equals 1.623.
So 8 minus 6.377.
No, it didn't come out to negative when you add the negative because you can't add to
So then why didn't we do a positive for the first one? Because that was log of x equals negative 0.245. So that would actually be log of x. So that would be 10 to the 0.245. You know what I'm saying?
No, I understand what you're saying.
So do you, I mean, in math, you don't add the negative. For this, do you add the negative for the anti-log?
Okay. Let me look at it. Okay, so pH minus the pKa is what? What'd you get?
1.623.
Equals the log of the base over the acid, right?
So in math, that's just 10 to the 1.623 equals x, base over acid.
Right, but that wouldn't give you a ratio.
That would be 41.98. That's a big ass ratio. Right? Because the top's 42 times the bottom. Which, I mean, that is a ratio, so 42 to 1.
Okay, well, do this. Take the take your pKa and take the log of that 42. What do you get?
1.623.
Okay, and you're going to add that to your pKa.
377 equals 8, so it is. You don't do a negative.
So
log
the
of
ratio
42
would need to be
is 41. 43.
43, right? Because if you took the log of 0.024, it would give you a negative number, right?
Right.
I guess remember just find the pH because it's negative log on the pH. So we use when you're doing the anti-log, it's anti-log, but you include the negative. But in this situation, you don't put the negative.
You don't put the negative because, yes, that's right. You don't put the negative. I'm sorry. Okay. So we need to fix this here. So x equals
41.98.
41.98. You got 47? This is telling me 41.7 over here. So 41.98. 47 seems a little higher than it should, but 42 is good enough. Okay. Okay, so that's how I'm going to find that. Okay, that ratio that I need there.
So wait, so we don't always put tends to negative it's not a negative number, or how?
Well, if you're going from the H plus ion, the pH to the H plus ion concentration, you have to put that negative back because it's the negative of the log, okay, to get there. But if you're going but in this case, we're just simply following the math. We want to follow the math. Okay. Now, if you guys had said, well, Mr. Crandall, they're asking calculate the ratio of H2CO3 plus that, they're saying what's the acid over the base, that's different, right? That's the reciprocal. That is 0.2024, right? 0.05. So if it was the acid over the base ratio, that's completely different. Then yes, it would be.
So whenever they're asking for the ratio, do we use the Henderson?
What's that?
Whenever they're asking for the ratio, we use the Henderson.
Henderson-Hasselbalch. Okay. This is the ratio of the base over the acid. Okay. What you guys had found.
Let's not do the other.
What was it? 2.5?
I'm sorry, 0.0248.
2.4? Which is just the reciprocal of that. I'm sorry, say again.
So which one's the right one?
Well, actually, for this question, they're asking for acid over the base. So it would be 0.024. But the correct ratio from the Henderson-Hasselbalch would be 41.98. And you could actually take one over this and find that. Okay, let's just stick with this right here.
What is that?
Okay, let's just stick with that.
It is 1 over, just a reciprocal.
Okay, let's just stick with that. Okay, guys, I don't want to confuse you. But this would be the ratio right here, 41.98. That is the ratio.
To be that, it has to be like calculate the ratio of add CO3 negative to the H2 CO3, right? Like the opposite.
Yeah, because of the way they've written it, they're asking for the acid over the base. But you guys calculated here 41.98, the base over the acid. Does that make sense? So if it was more clear, if they had maybe just said the ratio of this over this, still wouldn't have been clear. Acid over the base ratio versus instead of the base over the acid ratio. This is what you guys found, and then you take the reciprocal, you find.
But you have to find, you can't just do the log of A over B, right? Well, no, I guess.
not if you're using Henderson-Hasselbalch. If you switched it up, the POH plus the PK plus the POH
Okay.
equal, you could then do that way, but if you're using the Henderson-Hasselbalch as it's written, you're going to find the base over the acid.
Right. Gotcha.
That's what you're finding, the base over the acid. And then if you take the reciprocal of that, you'll find the acid over the base. Okay? Which I don't know how that helps you, but that's what the question is like. Okay. All right, so let's move on. Different kind of question. How much sodium hydroxide must be added to 1 liter of a buffer that is 1.8 molar acetic acid and 1.2 molar sodium acetate? Oh, and by the way, the Ka of acetic acid is 1.8 times 10 to the negative 5, okay? To result in a buffer solution of pH 5.22. So we have a 1 liter buffer that is 1.8 molar acetic acid and 1.2 molar sodium acetate. And we want the final pH to be 5.22. So try to unmuddle this in your head, what you're going to do. What am I going to do to solve for that? Any ideas? Where am I going to start?
You need the dilution.
No, because it's talking about moles into, so let's just say we're dissolving a solid. It's not changing the volume. So it just wants to know the moles. So the buffer, that is 1.8 molar acetic acid and 1.2 molar sodium acetate. Okay? And the final pH is 5.22. Sodium hydroxide is reacting with what? Acetic acid. And producing sodium acetate. Okay? So it's producing sodium acetate. So we have acetic acid, CH3COOH, plus OH minus is going to CH3COO minus plus H2O. Right?
What about the ALH?
Sorry?
The OH is
Just when you drop
the suspected right? I'm not saying
The sodium's a spectator ion. And that's why we don't include it here. Okay, so this is what's going to happen, and I'm going to end up with a certain amount of sodium acetate versus this to give me a pH of 5.22. Okay? The initial concentrations here are 1.8 molar of this and 1.2 molar of this. Okay? And this is what I want to know. It's in 1 liter. So whatever this comes out to be, the moles of this will be the molarity of it. Okay. Well, the molarity of that will be the moles of it. Okay. So this is, let's just say this is x, right? Minus x. This is going to go to 0. 1.8 minus x. And this is 1 plus x. 1.2 plus x. Okay? So, what am I going to do here? No, I don't want my KB. If this wasn't, if this didn't have x's and if this had numbers here, what would I do to solve for the pH? pH equals pKa plus the log of B over A. So it's the ratio again, right? I'm setting up this ratio right here, B over A. Okay? And then I have an equation and I have an x in it and I can solve for x. Okay? So do that. You know what pH is. Find your Ka. Ka is what? 4.74. Okay, I'll just go ahead and give you that. That's my Ka. I'm sorry, my pKa. My pKa, excuse me. My pKa equals 4.74. My pH equals 5.22. Okay, so pH equals the pKa plus the log of the base over the acid. 5.22 equals 4.74 plus the log of 1.2 molar, oops, I don't need molar, plus x divided by 1.8 minus x, all right? Okay, so let's simplify this. 5.22 minus 4.74 equals the log of 1.2 plus x divided by 1.8 minus x, which turns out to be 5.22 minus 4.74 is what? 0.48. 0.48. And then I equals the log of that, but I'll just go ahead and take the anti-log of it. 10 to the 0.48 equals 1.2 plus x over 1.8 minus x. Okay? So what does it come out to be? Is that x? Or
X.
what's 10 to the 0.48? 3 point, say it again, I'm sorry. 0, 2. You guys say it so fast. It's like, hear this, Mr. Grano. 3.028. Okay.
I heard you and understood.
Okay, good. I'm deaf, okay? Equals 1.2 plus x over 1.8 minus x, okay? And then, now let's just simply take this, multiply it over here, and solve for x.
What do you have that 10? Why did you do 10 to the?
This is the that's how I got rid of the log over here. I took the anti-log of it over here. So 5.22 minus 4.74 is 0.48, and I take the anti-log of that, 10 to 0.48, and I get 3.028. Okay? What'd you get?
1.05.
Okay. Ish. Okay, is anybody still struggling with this? Or are you doing okay? You always get something different.
Is that right?
Close enough. Yeah, that's. Yeah. They have 1.1, so if you round that, it's 1.1. So. We're not allowed to what?
We weren't allowed to use these.
Oh, I don't know. It's okay. It's just rounding. It's fine. Okay, so we have time for one more excellent question here. So this is a titration question. Titration is going to basically go into these, using the Henderson-Hasselbalch, because in a titration you don't start out with really a concentration of the base over the acid. You start with the acid and you titrate it with the base, but while you're doing that, you're creating some base. And then you can take those two concentrations, find the ratio, pH equals the pKa of that ratio. Okay, pKa plus the log of that ratio. So that's what we're going to do in these titration questions. In a titration, 12.5 molar of, that's not written down right, 12.5 milliliters of 0.5 molar H2SO4 neutralizes 50 milliliters of sodium hydroxide. Okay, this is a strong acid with a strong base, so this one's pretty straightforward. Okay, we're neutralizes that. What is the concentration of sodium hydroxide solution? This is a very basic titration question, but I want you to consider one thing here. 12.5 milliliters of 0.5 molar H2SO4 neutralizes 50 milliliters of sodium hydroxide. Okay, how many hydrogens do I have here? Two. So that makes a difference. Okay, so the ratio, the titration here, usually it's a 1-to-1 ratio. So the moles of the acid are equal to the moles of the base. But in this case, it's not. That's not exactly true. Okay, so this is the titration equation. BA equals MbVb. Okay. However, it's not quite that way because we have 1 mole of acid. 2 moles of acid for every 1 mole of base ratio. Okay. So that's going to kind of alter how I think about this equation. Okay, because there's 2 moles of A for every 1 mole of B.
So you get that by looking at the H?
H2. There's 2 hydrogens here that are going to neutralize the hydroxides. So if I use 12.5 milliliters of 0.5 molar H2SO4, okay, then I could directly find the moles of that if I wanted to, okay, and they would be not directly equal to the moles of the base, but they would be equal to it how? So if I have the moles of A, okay, moles of A to the moles of B, it's exactly 1/2 of it, right? So in other words, 2 MAVA equals MBVB.
So you aren't
No,
going.
I'm sorry. That
It's the other way.
was wrong. 1/2 of MAVA equals.
So we always did MAVA over moles equals MBVB over moles.
Over moles.
Yeah.
Okay. Okay. I've never used that equation, but okay. So that's the relationship here. Okay. Of how I would identify this. So this is a pretty straightforward question. Oops. Okay. So we could use that equation, or we could go ahead and solve for it. The moles of A equal the molarity times the liters. So we have equals 0.5 times 12.5. I'm sorry, not 12.5, but 0.0125 liters. Okay, so what are the moles of A? Say it louder.
0.0065.
Okay, and then like I said, I can relate those here. So if I divide that by 2, that'll give me the moles of B, which are what?
0.0031.
Okay, and that's the moles of the base. So what is the concentration of the base? How do I find that?
Moles over liters.
That's right. Moles over how many liters? What are the liters of the base in this question? 0.05 liters, right? Because it's 50 milliliters. Okay? Oh. Yes, you're right. It's because we have, so H2 plus 2 OHs. So you're right. I'm sorry. I was thinking about equals 2H2O. Because for every one H2, you have two OHs. So I'm sorry, I was thinking of more of two H2s, but it's one of these, one acid, you would have to have two sodium hydroxides. Okay? That's what I get for not writing out the equation.
That's the same thing. So half of your acids equals one hydrogen.
No, it's not, because let me show you. One, so stoichiometrically we have H2SO4 plus NaOH, okay, equals NaSO4 plus H2O, okay, and if I balance this, okay, then I have to have two of these reacting with every one of the H2SO4, okay, to give me the two waters that I need. Oh, and we're out of time. That's why you guys are leaving. So absolutely, it's one acid. I wrote this backwards. 1 mole of acid for every 2 moles of base. 2 moles for every 1 mole. So this would be doubled rather than in half. So that was right. That's right. Double it and then divide it by 0.05. That will give you the molarity. Times 2 divided by 0.05. Okay? All right. You okay with that now, Patrick? Sorry to confuse everybody. So one of these acids for every 2 base.
You don't really figure out moles, right? You just need to figure out the ratios.
So what is the concentration of sodium hydroxide? So what do you mean by the moles? Oh, you mean
For that,
this?
you're figuring out the concentration of the
Are you saying, can I use this?
Right.
Yeah, but you're going to have to alter it.
It's just going to be. You just do. What's the answer? Let me see that.
Yeah, 0.25. Yeah.
0.25 molar.
Yeah, okay. So how I set it up is, yeah, that's exactly right. That's fine. I figured it out, but I do MV over the mole, basically coefficient in that thing.
Oh, okay.
Equals MV over the coefficient.
So you would say 1 over 2? Yeah,
Then
okay.
you multiply the 2 over there,
Yeah.
and then, yeah.
So 2 MAVA equals
See,
MBVB.
the problem with that is, so we're gonna have to set up that. You have to set up the
You have to find you do need to find the ratio of acid to base if it's a diprotic acid. Okay, which there will be very few cases that you'll have that. Mostly it's going to be a monoprotic acid.
Exactly the other.
It's a possibility to have a diprotic acid, absolutely.
So we're gonna have a question.
So you have
like
to
this
set
on the
up,
test.
you have to
Like,
remember,
like their final?
You could.
you have to remember how to do all that.
this isn't. I mean, this isn't that hard. I mean, it's just
No.
like
But
the
on top
idea
of-
is that you
on
have
top of everything else, it can.
H2SO4 plus 2 sodium hydroxide. You have to have the. This is going to neutralize. One of these is going to neutralize two of those, right? One H2SO4 will neutralize 2 sodium hydroxides, and then you get the ratio 1 to 2 of the acid and the base. Okay, and
So-
what it's that ratio that helps us to see what the. After that, it's easy, right? So you just getting here though is the part that you're
That's
concerned
honestly
about.
the starting of everything in these acid base stuff is killing me. Let's have it set up.
Set up. See, was April in here? April was here.
Oh, Michelle?
Michelle.
Here. Because that's the.
Okay.
So, are you working on the certain like grammar and stuff like that with the radio paper?
No.
No?
No. I mean, have good grammar.
Yeah,
But no, I'm mostly looking at how well you.
Is there like a maximum, like how long you want it to be, or is everything like on your rubric?
I think it's all on there. I think I said make it this long. Just follow whatever the instructions.
Got a question about the P-Lab.
Oh, sure.
Not a question, actually a concern. Wrong. Wrongly. See this stuff too for the post lab?